Hello everyone, welcome to the video solution for Edexcel Mathematics Past Paper Solution. This is Core Mathematics C12 January 2018. This is fourth and the final video for the last two questions of this year. So let's start now. Question number 14. Figure 5 shows a sketch of the part of the line L with the equation y equal to 8 minus x and part of the curve C with the equation y equal to 14 plus 3x minus 2x square. The line L and the curve C intersect at the point A and point B as shown. Use algebra to find the coordinate of A and the coordinate of the point B. Okay, so A and B, these are point of intersection of two curves. So whenever the point of intersection, you say that at A, 2 points, two curves are intersecting. One is line and one is the curve. And the point B, this is again a point of intersection of the two curve. One is the parabola and the other one is the line. So whenever you need to find the point of intersection, so you need to solve their equation simultaneously. So you can have the value of coordinates for all the possible points. In this case, we have 2 points, so we can expect two different coordinates. So you say that the equation of the parabola is 14 plus 3x minus 2x square equal to y, and y is 8 minus x, so 8 minus x, and you just simplify this equation. So you can rearrange or you can rewrite this equation as if you send minus 2x on the other side, 3x and so on. So 2x square, 3x goes on the other side, so it becomes minus 3x, so minus 4x, and 8 minus 14, which is minus 6 equal to 0. Clearly you can use either a quadratic formula or maybe using factorization method. You can solve this equation. Then you have two values of x. So one value of x is minus 1 and the other value of x is 3. And clearly these are x coordinate of the 2 points A and B. And if you see the graph, x is equal to minus 1 is the x coordinate of the point A and x equal to 3 is the x coordinate of point B. But you need to find the coordinate, means x and y. How do you find x and y? You need to put these two values in any one of the equation, either equation of the parabola or maybe equation of the line. But of course line is a linear equation, so it's easy to solve. So I'm going to put one by one all these two values in equation of the line to figure out value of y. So if you put x equal to minus 1 in the equation of a line, so this is minus 1, so 8 minus minus 1, so 8 plus 1, so y is equal to 9. So minus 1 and 9, this is the coordinate of A. And if you put x equal to 3, so y is equal to 8 minus 3, 5, so y is equal to 5. So for A coordinate is minus 1 comma 9 and B coordinates 3 comma 5. Oh, sorry, it's not x, it's 3 comma 5. These are the coordinates. Okay, so the region R shown shaded in figure 5 is bounded by the coordinate axes, the line L and the curve C. Use algebraic integration to calculate the exact area of R. Okay, using integration, finding the area, the idea behind is, if you have any curve, this is x-axis, this is y-axis. If you have a curve of any shape, something like this, and if you need to find the area under the curve, like between these two vertical lines, suppose this is the vertical line like this, and you need to find the area under the curve above the x-axis. So you need equation of the curve y equal to f of x. You need equation of the curve, and you need these 2 points on the x-axis. So let's call it a and b. So a is called lower limit and b is called upper limit, and the area under the curve above the x-axis a is integral from a to b y dx. So you integrate equation of the curve between these 2 points in order to get the area under the curve above the x-axis. So in our condition we were given 2 different curves. It is not a simple case because this is the area bounded by 2 curves. So we generally divide our required area into different region to figure out the total area. And for this, the easiest way is from B I will draw a perpendicular line like this. So now you can see that, and I'm calling this point as give him some name. Let's call it maybe P. So OABP, this is a trapezium, and you can use trapezium formula to figure out area of this region. And this is the area under the line. I'm calling it area A1. And if you see, we have another area A2. This area is under the curve, which is a parabola. So you can use trapezium, area for trapezium, to figure out A1, and I'm not going to use this. I'm leaving this for you. But you have another approach. You can use equation of line to figure out the area under this line between 0 and P. So meaning our required total area is A1 plus A2, and now first we need to find A1. A1 is integral y dx. I'm not writing limit for the meantime, but I need to integrate equation of line, not the curve, because this is area under the line. So I need to integrate equation of the line, which is y equal to 8 minus x. That means 8 minus x dx. Now what about the limit? Limit is this point and this point. If you see, this is 0 0, that means lower limit starts from 0. What about the upper limit? If you see, the coordinate of B you have found in part A was 3 and 5, and this 3 is a x coordinate, so that means 3. So your limit is 0 to 3, so you need to integrate from 0 to 3. So A1 would be equal to 8x minus x square by 2. This is the integration of x, and the limit is 0 to 3. And after integral we need to apply limit. And how do we apply limit? Upper limit minus lower limit. So first I need to put upper limit everywhere in the integrand, and then 0. So if we put 3 first, so 8 times 3 minus 3 square by 2, this is upper limit, minus, I'm writing bracket for the safe side because sometime we got confused, so minus lower limit, but lower limit is 0 if you put 0 here or here, so overall answer is 0, so minus 0. So you have 8 times 3 is 24 minus 9 by 2, and if you simplify, your answer would be equal to 39 by 2. This is your A1. So A1 is 39 by 2. Okay, what about A2? A2 is the area bounded by the curve and the vertical line. That means for A2, I need to integrate equation of the curve. But what about the limit? So the lower limit would be 3 and the upper limit would be this point. And how can we find this point? So this point is the x-intercept of the curve. So you can substitute y equal to 0 to figure out the root or x coordinate. So before integration or before finding area A2, you need to find the upper limit. Okay, so remember I'm erasing it. So A1 equal to 39 by 2. So for A1, sorry, for A2 is, it was P coordinate 3. You need to find the coordinate of this point. So for A2 working, first of all, what I'm doing, I'm finding x-intercept of the curve. So 14 plus 3x minus 2x square equal to 0. And again, this is the coordinate equation. And if you solve these two, you have two values of x. X is equal to 3.5 and x is equal to some other negative number. Why am you, of course you can have a number, but the second number must be negative. Why am I saying this? Because they say these are the roots of the curve. Root mean the coordinate on the x-axis. So you see that this point is at the positive x-axis and this one will be the negative. So second value is the negative, but I don't need it, so I'm not wasting my time here. So the other point is 3.5. This is 3.5. So this is my upper limit. So now A2 would be equal to from 3 to 3.5 and integral of the curve. So 14 plus 3x minus 2x square dx. So if you integrate this, that will be, so A2 you will get, A2 would be equal to 31 upon 24. So 31 upon 24, this is your A2. Finally, your total area A is A1, which is this, and plus A2. So A1 you have already found, which was 39 upon 2 plus A2 is 31 by 24, and if you solve this, so A would be equal to 499 upon 24. This is your total area. I know this is a long method, but just for your trace I just give you idea. But if you use trapezium rule, so it will be quite easier than you think, because area of the trapezium A is half of A plus B divided by H. This A and B would be length of the parallel side and H would be distance between these two sides. So you can use A as the vertical height from B to P, and B you can use from 0 to this. So you need to figure out this height. Okay, so these two are parallel side and H is the distance between these two parallel. So this 3, in this case this 3 will be your H. So you can save your time and you must have the same answer as 39 by 2. Last question, question number 15. The binomial expansion in ascending power of x of 1 plus kx whole power n is 1 plus 36x plus 126kx square plus dot dot dot, where k is a non-zero constant and n is a positive integer. So show that nk in times of n minus 1 is equal to 252. Okay, so it's a binomial expansion and this is in the form of 1 plus kx. Meaning, if you recall your binomial expansion, so binomial expansion is if you have a 1 plus x whole power n, so you can expand it like 1 plus nx plus n minus 1 x square upon 2 factorial plus n minus 1 n minus 2 x cube upon 3 factorial, and so on. You can keep going on. So you can apply this to these two because I need to expand till 3 terms. That's why I'm expanding this. So 1 plus kx whole power n, and I can apply this binomial expansion. So 1 plus n kx plus n minus 1 and then kx. So k square x square upon 2 factorial. So now you can, because you need nk n minus 1, so you can compare the coefficient of x square with this. So here you have a coefficient of x square is 126k. Here in this expansion I have n minus 1 k square upon 2 factorial, and 2 factorial is 2, equal to, this is the coefficient of x square, coefficient of x square in a given expression, so 126k, and 1k is cancelled, 2 multiplied with the 126, so n minus 1 k equal to 252. This is our required condition, which is this. Part B, find the value of k and the value of n. So, if you see this, the second term in our general expression is nkx. So coefficient of x is nk, and the coefficient of x in a given expression is 36. So you can say that nk equal 36. So nk equal to 36. Now in our proved situation, if you see that n k n minus 1 is equal to 252. I did it just for so you can easily understand. This can be written as like that. So but nk is 36, so I can put nk here, which is 36. So I can rewrite 36 n minus 1 equal 252, and you can solve this for n, and n would be equal to 8, and you can substitute this n in this equation. So k would be equal to 9 by 2 or maybe 4.5. This is the value of k. Part C, using the value of k and n, find the coefficient of x cube in the binomial expansion of 1 plus kx to the power n. So I did not write here for the coefficient of x cube, but I can rewrite. So coefficient of x cube for part C is n minus 1, n minus 2, k cube, x cube divided by 3 factorial, because I have already found value of n and k, so I can substitute. So coefficient means I need only value for these. Okay, so I can substitute n and k. So n minus 1, so n is 8. That means 8 into 8 minus 1, 7 into 8 minus 2, 6, k cube, 4.5 cube divided by 3 factorial, which is 6. And if you solve this, you have a coefficient, like you can cancel this 6, you can take a 4 cube and then multiply all these numbers, so you have 5103. This is the coefficient of x cube as your final answer, part C. That's it for this video. Thank you very much. See you next time. Have a nice day.